Let us understand about the electric field. The electric field is essentially defined in order to understand how the electrostatic force of attraction or repulsion between two charges permeates through space. Let us say we have a test charge over here, and this test charge is small q naught. Let us say this test charge experiences a force F because of other charges present in the universe. Then we say that the electric field at the position of this particular test charge, namely the E vector, is equal to the net force F experienced by the test charge divided by the magnitude of the test charge. Ideally, we try to make the test charge as small as possible so that it does not end up distorting the other charge distributions in the surroundings. So this is how the electric field is defined to be. Let us study about the units of the electric field. Now from the definition of the electric field, we can clearly see that force is going to be equal to Q times the electric field. We know that force is measured in newtons and the charge Q is measured in coulombs. So electric field naturally will have a unit which would be newtons per coulomb. Now newtons can be written as kg meter second raised to minus 2, and coulombs can be written as ampere second. So in terms of the fundamental units of the electric field, we can say that the electric field essentially has the units of kg meter second raised to minus 3 into ampere raised to minus 1. So these can be said to be the fundamental units of the electric field. The electric field is visualized by drawing some things called as field lines. These field lines do not intersect and they are parallel-ish to each other. They are not exactly parallel, but they are, when we look at electric field lines that are nearby, then we can say that they are almost parallel when we analyze them in a small enough region of space. So even if they are not exactly perfectly parallel lines, we can consider them as parallel-ish when we analyze nearby regions or domains. Two different electrostatic field lines never intersect because the electric field E is given as the tangent to the electric field line at any given point. So if two lines were to intersect, then we would have a confusing scenario wherein one electric field line would say that okay, the electric field is in this direction, and let's say one electric field line was intersecting like this, then that line would say that the electric field is in this direction, because the electric field is always tangent to the given electric field line, and hence this confusing scenario does not arise because it is not possible for two different electric field lines to intersect. So electric force that mediates space and travels through even free space. The electric field travels to the free space, and electric field is a very good mechanism or a method to visualize what the electric force is and how it behaves and acts. And that is the reason why we define the electric field. Now, let us understand how to visualize the electric force on point charges. In the given diagram, the electric field in both the cases is pointing rightward as shown in the diagram. In case 1, we have a positive point charge, and in case 2, we have a negative point charge. The force, as we know, is given as Q times E. So here plus Q is present, so the force will be plus Q times E. And the direction of the force will be the direction of the electric field. In short, the direction of force on a positive charge is same as the direction of the electric field. Here, the direction of force we can see is opposite to the direction of the electric field because we are multiplying with the negative charge. So while taking the direction of force, we have to take the direction of the electric field, multiply it with the magnitude of the charge, and also take into consideration the sign. So if there is positive sign over here, then the direction of the force is the same as the direction of the electric field, and if there is a negative sign over here, that is for negative charges, the force is opposite to the direction of the electric field.